Hello students, this video is powered by synthesis tutorials. So in the previous session we were done till question number 2 of this particular exercise, E exercise. Now in this session we'll be continuing from question number 3. Alright, so this is our question number 3. So question number 3 says what, children? It says from a rectangular solid of metal 42 centimeter by 30 by 20. Okay, so basically this is this is a cuboid that we are talking about, a conical cavity of diameter 14 centimeter and there 24 centimeter is drilled out. Okay, so this is what they are saying. Now what does this mean, children? This means that suppose there is this box which is there, suppose this is the rectangular box. So rectangular box in the sense, children, this is a cuboid. Okay, so suppose this is my cuboid and from this what I am doing, I am just taking out I am making a conical cavity. So suppose this is my conical cavity which I am making. Okay, and then 42 by 30. So means what, children? What is the dimensions that have been given? I'll be just writing down. It has been given as 42. Okay, and then this is 20 the breadth and the height has been given as 42 is the length, children. Okay, so this is our length. Then we have height is equal to 30 centimeter. Then you are taking out a cone whose depth is 24. Depth is 24 means what, children? And diameter is 14. So diameter is 14 means, children, it's actually a small one. So it will be like this. Wait, diameter 14 means suppose it's like this much and then its height has been given as this much, 24. So you are just digging out this conical figure out of it. Okay, and this conical figure has got a height of how much? It has got a height of 24 and the radius which is there, the diameter has been given 14, so the radius actually is 7. Okay, so now what you need to calculate? You need to calculate the surface area of the remaining solid. So this is going to be a very easy one, children, because you have to find out what you have to consider. First of all, the outside the rectangular box or the cuboid. So for that you will be finding out what? You will be finding out, this is actually not that easy also, children. So basically, since if you had to find out the volume, then things would have been easier, but since here you need to find out the surface area, therefore you have to clearly understand that what is happening. So here what is happening, children? Here what will be the surface area? The surface area will be, rest of the 5 sides will be there, but for the base 6 side it will be actually this figure. You just note down the red lines, children, which I have drawn, and these red lines are the area that you need to find out. Okay, and that will be the surface area. So means what? It is starting from here. If you look at into this, children, I'll be using green now. This particular surface I need to find out, the ones which I am marking. So this is going to be the surface area of the solid from here, and then for this cone. So if you see what it will be, children, it will be actually equal to, see, you will be taking curved surface area of this particular cylinder, that is fine, but then what else, what you will be doing? You will be calculating the total surface area of this particular solid as well, but from that you will be excluding the surface area of this circle. Why this circle, children? Because this is not included in the figure, because that is a part that you are excluding. So first what you will be doing? First you will be finding out the total surface area of this particular solid, and then you will be finding out the curved surface area of this particular cone, and then what you will be doing? We will be just subtracting the area of this particular circle from this figure. Okay, so this is the question all about. So how are we going to do? Just clearly look into it, children. So this is what, children, this type of exercise, children, everything is easy if you actually know what you have to find out. If you are done with that part, then this is going to be an easy one. Okay, so for that what you will be writing? For cuboid, L has been given as how much? L has been given as 40, B has been given as 30, and H Okay, B, we are to take B as 30 children. Is it like this? Just a second. Okay, yes. So you need to take B as 30. So basically, because it actually doesn't make a difference, children, because ultimately everything is going to be multiplied. So it's completely up to you that which one you are going to take this, which one you are going to take length, which one you are going to take breadth, and which one you are going to take height. Here, why did I take 30 as height? Because, children, if I am taking 20, then what will happen? Then I cannot dig out a 24 centimeter height from that. Okay, so I'll be taking this as B, I'll be taking as 20, and we'll be seeing whether the answer comes out right or not, children. This has to come out right anyways. So what will be the TSA? The formula of TSA is what? This is 2 into, if you remember, LB plus BH plus H into L. Is this the formula? So just replace the value. 2 into length has been given as 42 into 20 plus 20 into 30 plus 30 into 42. Okay, so this comes out to be how much? 2 into, this is 840 plus 600 plus this is coming out to be 1260. So this in turn is equal to 2 into, so 600 plus 1200 is 1800, 1800 plus 900 is 2700. So this is 2700. So this comes out to be 5400, children. So 5400 centimeter square is the surface area of this particular rectangular box which is there, or the cuboid. Now what you will be finding out, you have to find out the curved surface area of what? You need to find out the curved surface area of the cone. For cone, what you will be writing? So for cone, I have been given radius, which is equal to how much? 14 is the diameter, so the radius is equal to 7. Then I have been given the depth, that is height, is equal to 24 centimeter. Okay, so now what I will be doing, so for calculating the surface area, it's evident that I need to know the slant height. So what I will be doing, L is equal to root over of R square plus H square. So this in turn is equal to root over of 24 square plus 7 square. So when you calculate, this comes out to be 25, children. 576 plus 49 is 625, whose root over is 25. So now what you will be calculating, you will be calculating the curved surface area is equal to, it will be equal to pi r into L. So this comes out to be 22 upon 7 into r is 7 into 25. So this is getting cancelled. So 25 into 22 is 50 into 11, which is 550. Okay, so write down that this you are getting as equal to 550 centimeter square. Okay, so now what you will be doing, you need to now find out, you have found out for the total figure, you have found out for the cone, now you need to find out for the circle. Okay, the circular base which is there. Then write down area of base, not base, children, since it is circular, so you will be writing down area of circular base will be equal to pi into r square, which in turn is equal to 22 upon 7 into r is equal to how much, children? R will be the radius of the cone, which was equal to 7 into 7. So this comes out to be 22 into 7 is 154 centimeter square. Okay, so now what you will be doing, here we have 5400, so I'll be writing down 5400 here so that I remember. I'll be erasing rest of the part, and now I'll be finding out the TSA of, so this is a lengthier question, children, so I'll be writing down what? Surface area of solid is equal to surface area of cuboid plus surface area of cone plus surface area of cone plus, minus surface area of circular base. Okay, so this is what we are getting. So surface area of cuboid we calculated as 5400 plus surface area of cone we calculated as 550, and then minus we'll be doing 154. So how much is this coming out to be, children? 5400 plus 550 is equal to 5950, minus 154 should be equal to how much? This should be equal to 5796 centimeter square. So this is the answer of your first sub question, that the area of the remaining solid is equal to 5796 centimeter square. So this is just the first question. Okay, so now we'll be moving to the second sub question, which says the volume of remaining solid. So this is very easy one, children. Volume, how can you find out? Volume means you will be finding out the volume of this particular cone, and then for cuboid, and then you will be finding out the volume of cone, and then you can easily subtract to find out the volume. Okay, so second sub question, children, you can easily take as homework. Why? Because what do you have to do? I'll be just telling you that. So for that you will be taking as what? See, you will be taking, so suppose this is my question number 3. Here what I'll be, second sub question, so here I'll be taking for cone, and then I'll be taking for cuboid. So the formula of cone is what? It is 1/3 into pi r square h. So you have all the values, you can just take them, and for cuboid it is L into B into H. So you can just find out the volume of this, and you can just find out the volume of cuboid. So the volume of material remaining solid will be equal to volume of cuboid minus volume of cone. Okay, so this way you can do. Now the third is weight of the material drilled out. So what is the material that is drilled out, children? Out if it weighs, so what you will be writing, 1 centimeter cube is equal to 7 gram, and then what is it is drilled out? Drilled out is actually the volume of the cone. So you will be calculating volume of the cone here. So 1 centimeter cube is equal to 7 grams. So this much centimeter cube will be equal to this much into 7 gram. Okay, so here what you will be doing, volume of the cone into 7. That's it. Okay, so this third sub question also you are going to take as homework. We will be now moving to question number 4. Okay, so we'll be quickly looking into it. So in question number 4, the question says what, children? It says there is a cubical block of side 7 centimeter is surmounted by a hemisphere of the larger size. Okay, so you have to first see to it that what is the figure that comes out, children. A cubical block of side 7 centimeter. Okay, so there is a cubical block. So what is cubical means, children? Cubical means that it has all the sides, it's a cube, all the sides equal. So this is a cubical box. Okay, is surmounted by a hemisphere of the largest size. So when they say of largest size means what? Suppose, children, if I want to, this is a 3D figure. If I just draw a 2D figure of a cubical box, this will be like this. So here of the largest size means what? Means it means that the radius of this particular will be equal to the side of this particular cube. Okay, so this is the largest side. Find the surface area of the resulting solid. Okay, so you have to find out the surface area of resulting solid, means whatever is the surface area that you are getting. So here this is also going to be an easy one, children, in the sense what you have to do. This is question number 4 I'll be telling you. So here first you will be calculating what? You will be calculating the curved surface area of the hemisphere. So for hemisphere, what is the curved surface area, children? The curved surface area is given by 2 pi r square, and then what will you take it as height, because they are saying that largest size. So the r will be taken as what? R will be taken as 7/2. Why? Because clearly here you can see here that this diameter is equal to side of the cube. So side of the cube is 7, so its radius will be equal to how much? Its radius will be equal to 7/2. So here r you will be taking as 7/2, and you can just calculate the surface area. Now what you have to do, you have to calculate the surface area of this particular, the down cube which is there. Okay, so for down cube, if you see for the other 5 sides which are there, because this is a 3D figure, children, as I told you. Okay, so for rest of the sides, so how many sides are there? We are having total 6 sides. So for 5 sides the surface area will be equal to 5 into side square. But what happens for the topmost side? So the topmost side will be the, see, the you will be taking the, see what are you going to do? Area of the base. Suppose I'll be telling you this, you will be taking the area of the topmost figure, children. So suppose this is my topmost, okay, and then here you will be subtracting what? You will be subtracting the area of base of the hemisphere. Okay, all right. So what will be the area of base of hemisphere? That will be again equal to pi r square, because ultimately whatever is touching this particular is forming a circle, because whenever this hemisphere, this is touching this cube, children, so on the, when it is being kept on the top, it is actually forming a circle. Okay, so circle means what, children? Its area will be given by pi r square. Okay, so what you will be doing here, I'll just do it for you. So for hemisphere you have calculated that this is the, what will be the surface area? This is 2 into 22 upon 7 into r, you are taking 7 upon 2 into 7 upon 2. So this gets cancelled, so you are getting 77. So what you will be writing now? You will be writing for the cube. So for cube, what you will be writing? For 5 sides except top, what will be the area? Okay, surface area will be equal to 5 into side square. Why, children? Because for one face it is side square. So for 5 faces means, children, this face, downward, this side and the other side. So out of 6, the 5 faces, it will be equal to 5 into side square. So this in turn is equal to 5 into side is equal to how much, children? It has been given as 7. So this is 5 into 7 square, so which comes out to be 5 into 49, which is equal to how much? This is equal to 245 centimeter square. So this you are calculating for the other sides. Now you have to calculate for the top. So what you will be writing for the top of the cube? For top of the cube, what you will be writing? Surface area will be equal to surface area of top of the cube, minus surface area, or only the area of circular base of hemisphere. Okay, so this is what is the important formula here. It's not a formula, children, it's just the way you are writing. So what you will be writing, this 777 that we are getting, I'll be writing down this side because I need to erase. So I'll be just erasing this part now. So, or for the other 5 parts, I calculated as 245. So this is also what I'll be writing. So for the top, I am getting how much? Surface area of the top cube will be how much, children? It was just equal to side square. So this is side square minus, for circular part, it will be equal to pi into r square. That is the area of the circle. So side square means this is 7 square minus 22 upon 7 into r is equal to how much, children? We have calculated 7 upon 2 into 7 upon 2. So this is getting cancelled. So you are getting what? You are getting 49 minus 77 upon 2. So this actually will be equal to how much? This is equal to 49 minus 77 upon 2 is equal to how much, children? This is 38.5. So 49 minus 38.5 is 10.5 centimeter square. So on the top we are having 10.5 centimeter square. Okay, so what we'll be writing? Therefore, surface area of resulting solid, write down, therefore, surface area of resulting solid is equal to, see, you will be writing SA of hemisphere plus SA of surface area of the 5 sides plus surface area of top of cube. So for hemisphere, how much you have calculated, children? For hemisphere you have calculated at 77, plus for 5 sides you had calculated as 245, and then for the top we have calculated as not 243, children, it's 245. For top it is 10.5, and then this all combined gives centimeter square. Okay, so how much is this? 245 plus 10 is 255, plus 77 is coming out to be 332. So this is 332.5 centimeter square. So this is the answer that you are getting, that this is the surface area of the entire figure which is there. Alright, so this is the way this particular sum has to be done. We'll move on to question number 5, children. If you just look into this, so question number 5 says a vessel is in the form of inverted cone. Its height is this and radius of the top, which is open, is this much. It is filled with water up to rim. When the lead shots, each of which is a sphere of radius this much, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots that are dropped. So this question is an easy one, children. So I'll be just explaining you how to do, because the question of this type we have done already. So what you will be writing down first, I'm just writing down the hint, children. So here I'll be writing down for cone, and then here I'll be finding for sphere. Okay, so for cone first you will be calculating what, children? The radius has been given as 5 centimeter and the height has been given as 8 centimeter. Okay, so what you can be writing, that the volume will be equal to 1/3 pi r square h. So you will be calculating the volume, and then what they are saying, 1/4 of the water is coming out. Okay, so for that what you will be doing, children, you will be writing down like this, that see, for sphere, what is the lead shots that are giving? What is the sphere? So this is radius here has been given as 0.5 centimeter. So this is equal to half. So you will be finding out the volume, which will be equal to 4/3 into pi r cube. Okay, so now they are saying this you will be calculating, and this volume of the sphere is actually equal to how much? This volume will be equal to 1/4 of the volume of the cone. So whatever volume you have calculated here, children, you will be doing 1/4 of it, and then you will be just calculating the value. So this will be your total value of the total volume divided by, suppose this is V1, so this is V1. So 1/4 of, not this one is V1, children. Suppose after doing 1/4 you are getting V1, I will be using different pen. Okay, so this volume you will be taking in the numerator, and this will be divided by the volume of each cube, that is V2. So when you divide, you will be getting the answer. Alright, this is the way this particular sum has to be done. Means what, children? Whatever is the volume of the cone, 1/4 of its volume is coming out. So means what? That much is the volume of the spheres. So we are doing 1/4 of this to get the volume of spheres, and now the number of spheres will be equal to, I'll write down the formula here, that number of spheres is equal to total volume divided by volume of each sphere. Okay, so total volume divided by volume of each sphere. Okay, so this way you will be doing this particular sum. So it's an easy one, children. This you can be easily taking as homework.